Okay, so now that we've got our stretchy IK in place on our leg, let's turn around and set up the twist control for that IK chain. So I'm going to go ahead, jump over to our whiteboard, and let's first discuss what exactly it is we wanted in terms of a leg twist control, and then we can turn around and talk about how we're going to achieve that kind of control setup. So we've got our leg, and we've got our leg with the upper leg and lower leg, and that has IK with an IK handle, and we said that we want a control object that's a rotational control that sits out in front of our knee, but instead of having its pivot point through the center of that control, that pivot point needs to be offset back to the axis in which the twist actually takes place. And if you recall back to when we discussed inverse kinematics and technical rigging 3, we discussed that the twist rotation takes place upon an axis that goes from the start of the bone chain down through to the end effector. So that's the axis the twist rotation takes place on, and we need to offset back to that axis in order to find our pivot point for that rotation. Now, in order to do that, you can probably tell that we need to know about this axis. If we're to offset to that point, if we're to rotate about that axis, we need to know about the axis both in terms of position and in terms of orientation so that we can rotate about it. To do that, what I'm going to do is create a null that aims along that axis. We know that that axis goes from the start of our bone chain down to the end effector. If we create a null at one of these locations and aim it at the other location, that will give us that axis. It will also give us an axis that runs perpendicular to this axis at 90 degrees to this axis, which is fantastic because that is the exact axis that we need to offset our pivot point along in order to match the pivot point into the correct location. So it's actually going to give us two things. So let's turn around and look at how we're going to set up that null to give us that orientation. We've got our leg, and we have our IK handle. We can create a null that exists at the start of our bone chain, and we can tell it to aim at the IK handle. That will give us an axis going from the start of the bone chain down to the IK handle. Now, in terms of our network, we actually have two different nodes that we could become a child of. We know that both the hip and the upper leg have their origin at the start of the bone chain. That means we could be a child of either of these nodes, and that would enable us to be in the correct position to aim down at the end effector and give us the axis that we were after. However, one of these nodes is going to actually give us an advantage over the other node. We know that we always want our control object to sit out in front of the knee. That means we always want to have a perpendicular axis that points out towards the front of the leg. If we have a null that is a child of the hip, that perpendicular axis will always point out towards the front of the hip, not necessarily point out towards the front of the leg. If we were to apply a twist to the leg, that means the leg has been rotated, the leg's orientation is different to our hip's orientation. However, if we had a null that was a child of the leg, no matter where the leg faces, it's going to inherit that orientation and then aim at our null and aim at our end effector. That means that we're going to inherit that orientation as part of that aiming, and in terms of that orientation, our perpendicular axis to the aim axis will always point out to the front of the leg. That's going to be very, very convenient for us because it means that we can always know which way points to the front of the leg and thus offset our control out to the front of the leg. So with that in place, we have the ability now to say, okay, I want to create a null that is a child of my upper leg, and I want to tell it to aim down at our end effector. So we'd have a null that sits up here, and we want to tell it to aim at our end effector. The default settings for this aim are actually going to pose an issue. Let's think about this. Our leg is set up in such a way that by default, we're kind of looking like this, with this being our world y-axis. This is obviously our z-axis, and x is currently facing straight towards us. If we were to have our null set up and aiming down, we can see that that aim axis is very close, if not identical, to the world y-axis. By default, the up vector for that look at is set to world Y, and this will cause problems because if we have an up vector equal to our aim vector, we cannot calculate the perpendicular. We'll end up with things spinning around and it will become a huge mess. We need to make sure that our up vector is a vector that as far as possible will never be hit by the look at vector. We can also see that Z facing out towards the front of our character could quite easily become a look at vector as well as our up vector if our ankle was to move out in front of our hip. Unlikely is that our ankle will move out to the side of our hip. So we can see that if we were to set our up vector to be equal to world X, that would give us our up vector that points out in world X as opposed to pointing down in world Y, which is very similar to our look at vector. So we can set that up vector to be world X, and that means they're going to have the least amount of chance of hitting the same axis as our aim vector, and that means we're going to get the least amount of issues in terms of things spinning around or not working correctly. So we can have a null that we set to have its up vector to be the x-axis. We're going to tell it to look at our end effector, and it's also going to be inheriting some orientations from our upper leg, which means that we're going to get a null that aims itself down at the end effector and points out towards the front of the leg. And because of the way that we specify x as our up axis, we're going to get orientation such that negative z points down the aim, positive z points up away from the aim, positive x points out to the front of our leg, and negative x points back to the back of the leg. And this will always be the case, which means we now know the axis we need to rotate around, that is the z-axis in the local orientation of that aimer null. We also know the axis in which we need to offset our pivot point on. That will be the x-axis in this local orientation, since that will take us perpendicular to the axis of rotation and allow us to offset our pivot point back to the correct axis. So now that we've got that orientation in place, we can use it down on our knee. We can create a null that is a child of our lower leg, and that means we're going to get a null that comes in oriented something like so with our lower leg, but we can tell it to reference the orientation of our aimer null, and that means that we're going to come in and we're going to reference that orientation, meaning that we'd have a null that sits at our knee but has positive x facing this way, positive z facing this way. So we have the exact same orientation, we just have a different position. This is going to be very useful to us because we're basing ourselves from the knee. If we then offset in a direction that we know to be in front of the knee from that known knee location, we can place our control so it always sits in front of the knee. Also, because we're oriented in such a way that we're oriented same as our aimer null, that means we know if we rotate about a z axis, that means we're going to be rotating about that twist axis. We also know if we offset our pivot point along this x-axis, we can offset it in such a way that we reach back to that twist axis. So because we have that orientation, it's going to be incredibly useful to us. So we've got that orientation in place. We're going to do that by changing the rotations on our null to match the orientation of our aimer. We can also go ahead and offset in front of our knee. We could do this with two nodes. We could have this node set up to give us the orientation, then a child node set up in such a way that we then offset from that point along the positive local x-axis. In actual fact, what I'm going to do is make use of our transform order. If we rotate first and then translate, that's the same as having two nulls. Instead of using two nulls, I'm going to use just the one. I'm going to rotate first to get this orientation. Then I'm going to translate by a positive 1 along the local x-axis, moving us out in front of the leg. So now that we're set out in front of the knee, we can create a child of that particular location and orientation, and that child will become our twist control, but its pivot point is still going to sit here. Its axis of rotation for Z is indeed correct. That does indeed align. Let's just clean up that diagram a little bit. Let's grab the eraser, clean up the diagram just a tad. Grab our brush and clean this back up. Fantastic. So we know that our axis is indeed parallel to the correct axis, but the pivot point needs to be offset back. We can do that because we know that that offset will occur on the local x-axis. We can say, what is my position in x compared to the position in X of that original aimer null. We can offset based on the difference between those and offset our pivot point back to here. If we then take our rotate in Z and we use that to drive the IK twist parameter down on our inverse kinematics, that will allow us to twist our leg about that twist axis. We are going to have an issue, however. We are going to get double transformations. We're rotating our control object, and that means that our control object obviously will be affected by that rotation about that pivot point and will be rotated about that point. So let's draw a top view of what we might see. So this is our upper leg going to our knee. I won't bother with the lower leg. Here's our control object, and let's stipulate that this happens to be our pivot point for the rotation. That means if I was to rotate in Z, we'd rotate around and we'd end up being oriented now here, because we've rotated about this pivot point. We've offset our pivot back to that location. So we've rotated in Z, but then we've said, okay, use that rotation to drive the twist on our IK. That means our bones are now going to rotate to be oriented in this way. But our control object is a child of those bones. So that means that our control object is also going to inherit that rotation, and he's going to move twice. He's going to move once for his own rotation and once because we've driven the bones with that rotation as well. To counter this, to bring our control object back to its proper location, the location sat outside in front of the knee, what I'm going to do is I'm going to counter the double rotation by coming back 1 times that rotation. That means we're going to rotate ourselves, we're going to rotate because of the bones, and we're also going to have a parent null of ourselves that has the exact same pivot point but cancels the rotation by rotating back the exact same amount that we rotated forwards. That will bring us back to the correct location and have us sat out in front of the knee. So with that, that's a look at how we're going to approach the setup of that twist control. In the next video, we'll turn around and actually get that control implemented. Thanks a lot.